So these kind of questions from this morning, they break the questions down very nicely for you, right? Where it's like, okay, we go, for instance, we go 8 kilometers in the east direction, right? Keeping in mind, if we drew our compass, we have northeast, south, and west. So I'd be traveling in the east direction 8 kilometers, and then I went 6 kilometers in the north direction, right? And then we were able to say, okay, well, my resultant, or where, like my displacement, for instance, right, would be this blue arrow, right, this blue vector. And this was all fine and dandy. You'd be able to do the work from this morning using Pythagorean theorem to solve for the magnitude, and then you'd use tangent to find the angle. Nothing too crazy, right? This is almost like a solve this triangle question. That's all this is. This is all this is a solve this triangle question from like grade 10 or grade 9, where you have to like solve for all the side lengths, solve for the angles, right? That's all this is. But we run into an issue, and the issue is, in physics in particular, what happens if I don't spell this very nicely out for you? And I tell you what these two pieces or components are, right? That's what this word is. Components. What if I don't tell you what that is, and I only tell you what the displacement vector is? It's whatever it is. It could be, I don't know. I'm gonna make one up. 10 kilometers north 30 degrees. Or sorry, that's east 30 degrees north. What if I gave you this and asked you to find these two pieces? Then you'd be in some trouble, right? You'd be like, oh, I don't have those two pieces. That's what I'm trying to find, right? That's what we're doing this morning or this afternoon, right? We're going to take a vector that's been given to us. It doesn't matter what kind of vector it is. If it doesn't matter if it's a force vector that we're going to see in the next unit, an acceleration, a velocity, a displacement. It's just a vector. Like, we're just going to take a vector and we're going to break it into the two pieces that make it up. In this case, the two pieces would have been 8 and 6. Okay, and this is something that I kind of struggled with for a long time, right? Until I kind of nobody really explained it to me in a way that quite made sense. What I'll do is I'll try to spell it out as clearly as possible here, okay, using colors and different kinds of whatever, right? Whatever you guys need, okay? Colors seems to work for me. This, once I realize what the colors, oh, that's weird. I completely tried to make up a vector, and I subconsciously pulled this question out. Okay, that's really weird. I didn't mean for that to happen. But anyway, so here's what we're gonna do. I want you guys to get proud. You're gonna need to do a few different things here, right? I'll draw the actual displacement vector. This looks like I know it's a displacement vector, sorry. It's displacement. I know it's displacement because the units are in meters. Okay? If it was meters per second, then I'd know it was a velocity vector. And if it was meters per second squared, I know it was an acceleration vector, for instance, right? So, and if it was in newtons, it'd be a force vector. Okay? So, here's what you got. You guys you're gonna have to be able to like draw that vector. And I'm not too sure if you would have come across that. Maybe in the 3U math, actually. Oh, I'm thinking about it. In some of the trig section, I would think, right? So what you're gonna have to do is be able to draw this vector. Like, where is this thing? Is your question, right? Well, here's what you got. I always like drawing. You can draw a big coordinate system, right? I'll try to draw it straight. Okay. You're going to have a coordinate system. You're going to follow the normal rules like north, east, south, and west. And you know, okay, so here's what you got. You're traveling in the east direction. That's what this is telling you. So you're going in the east direction, right? And then you're going to go 30 degrees north. Okay, so you're going to get this like kind of resultant vector here. right, that you know is going to be 10, and you're going at an angle of 30 degrees. That's how you read this, okay? And so your question might be, okay, well, how far in the x direction and how far in the y direction did I go? So how far in the east and how far in the north? Those are your questions, right? And what I like to do is we call these things, we call them an x component and we call them a y component. Oh, I'm going to run out of room. Okay, so every vector that's provided to you, in this case, we get 10 meters east, 30 degrees north. That's a vector, it's a displacement vector. Every vector that's given to you will have two components in 2D, I suppose, in two components. If this was a vector in 3D, in 3 space, where we're saying x, y, and z, then every vector in x, y, and z would have 3 components. You'd have how far in the x did I go, how far in the y, and how far in the z. Nothing's changed. It's just a vector. Okay. So what you guys are going to, we're not going to deal with 3 space. That's not on our radar. Even for the grade 12, it's not on our radar. Okay. That's like a well into university stage. What is on our radar is being able to take forces or vectors in 2 dimensions. Remember, that's what we're doing. We're looking at motion in 2 dimensions and breaking that motion in 2 dimensions into its 2 pieces. One of which is an x piece, which I'll write in red, and one is the blue piece. When I add the red piece, what this is saying, like I'll have a, let's say I have the black piece will be our actual magnitude, right? If I were to write c squared has to equal x squared plus y squared. Oops, I want to write it in blue. Okay, that's where this is coming from. So when I square the red piece and I square the blue piece and I add them together and I square roots, I get the black piece. That's what this morning said. Except this morning I gave you the values of the red piece and the blue piece. Okay, that's the only thing that's changing from this morning to this afternoon. Okay, can you guys, is that coming across to you guys okay? Like, I just want to make sure that we're okay before I go any further. Because if you guys drop in the chat that is okay, then we'll be okay. All right, and I'll go further. Okay. So your goal this afternoon is you're given a vector, which we're all experienced with now. It will look like what I have in this little blue box here, right? You got to be able to draw it, and then you have to dissect it into its 2 pieces. That's what I'm going to show you right now. How to get the red piece, how to get the y piece. And it's just trigonometry. Okay, SOHCAHTOA, that's it. Okay, so when I bounce back here, this is where this is coming from. I'm going to move this. I'm going to shrink it and move it because I think it's important in terms of context where everything's... Ooh, you guys can't see that. I don't want to see that, though. Okay, kind of stuck here. I've got stuff. I hid the answers underneath. I forgot to delete them originally. Okay, so we're stuck. So here's what we're going to do. I'm going to do the work in the red in red. Okay, for the red, the x component. Okay, so I want to figure out what that the value of that red piece is. Okay, and here's how you do it. If you guys are standing, remember this is just how I explain trigonometry. I'm standing here, and you guys want to be able to label the side lengths. So I'm going to stand at the angle of interest. In this case, it's 30 degrees. And when I look directly across from me, I see the opposite. And then directly beside me is what we call the adjacent. And then the big side length, or the one opposite to, and remember there's a 90 degree down here in this corner, the big side length opposite the big angle, 90 degrees, is what we call the hypotenuse. Okay, so now we've identified x is our adjacent, y is the opposite, and the black piece is our hypotenuse. Okay, so here's what we need to do. If you guys were to write SOHCAHTOA, like you've probably done so many times in your life, okay, you need to look at these things and come up with, okay, which one can I use where? Well, let's just start with, I'll start with the y piece, for instance, okay? The y piece is opposite. How could I possibly figure out what that opposite side length is equal to? Well, you know two pieces of information, right? So why don't you pick the trigonomic ratio, or sine, cos, or tan is the ratio, and pick the appropriate one that fits what you have and what you're looking for. Remember, you have the angle as well, right? So why can't you say, okay, the blue piece for this black vector, this vector here, will be equal to the sine of 30 degrees, which will be equal to, remember sine theta is equal to opposite over hypotenuse. We're going to say, okay, well, I don't know what opposite is, so we'll call it y, right? The y component over the hypotenuse, 10. How do you get y? Multiply both sides by 10. Right? They cancel. So you get y equals 10 sine 30, which should equal, let me check my answer here, 5. You guys should know too. I should know as well, but I forgot. The sine of 30 is 0.5. You guys would have learned that with in your trig unit, right? Your identities, not identities, but the wonderful circle. Okay, you guys should know that the sine of 30 degrees is 0.5. And so you'd get 10 times 0.5, which would equal 5. And that'll be in units of meters, right? Because the original vector is in meters. Okay, so that means, what does that mean? It means that if this was an ant or something, it means that the ant traveled 5 meters in the north direction. Are we okay? You have to do the exact same work. That's just one piece, right? Don't forget every vector that you draw in this course and in grade 12 courses, right? In grade 12 physics, is going to have 2 components. One represents the x direction, or horizontal, and one represents the vertical. Okay, we just found the vertical, the north direction, right? It traveled 5 meters in the north direction. Now I want to figure out how far in the east direction did this thing travel. Okay, well, let's switch over to the red. How could I find the x component, right? Well, the x component is labeled adjacent. So which trig ratio am I going to use? Well, I need to still use the information that's provided to me in the question. I need adjacent, but I know hypotenuse, and I also know the angle. So I'm just going to go, okay, not sine, cosine of 30 degrees will equal x. I need to find x this time. It's adjacent. Remember, the cosine of theta is equal to adjacent over hypotenuse. You know hypotenuse, it didn't change. It's still 10, right? Right? And so you know that the hypotenuse is 10, so that's where that's going to go. And here's what you get. Same thing. Multiply both sides by 10, right? They cancel. You get x equals the cosine, 10 times cos 30. What is the cosine of 30? Once you know it. Yeah, Jagger, you could do that as well. The thing is and it becomes a little bit more, it's just faster, because what ends up happening, Jagger, is that this is just going to like work every time almost, right? So you don't want to have to sit here and do this. You could, but you don't want to, right? I would advise just do this. I would say, okay, x is, this is typically going to work every time, right? Where you're going to get y is going to be associated with the sine 30. Well, you can't see it, sorry, because there's stuff over top. And then x's are always going to be kind of associated with the cosine, for the most part. There will be instances where that is not the rule, and we will come across those instances. For the first unit, though, that's pretty much typical, I would say, if I'm not mistaken, but I'm pretty sure, for kinematics. I can't think of an instance where that wouldn't be the case. Okay? So then you just do the math. I think this is, you just type in your calculator. You just go 10, whatever the cosine of 30 is. That should be, I should know that as well. Maybe not, actually. 0. If you guys were to type 866, sorry, not 87, 866, right? And so we're going to get 8.7. What's going on here? Yeah, I'm right. Okay, so that means, this means the ant traveled, or whatever it is we're talking about, ants traveled 8.7 meters in the east direction. Okay? Did we have any problems? Trust me, like, Jack is right, you guys could use Pythagorean theorem and back calculate. That's kind of a pain. I would prefer just to do this. Right? If I give you a vector, which we'll see more of tomorrow, I'm going to start the hard stuff tomorrow. Not hard stuff, just applications of this. You'll see that I just want to go 10 sine 30, 10 cos 30, and figure out the two pieces and be done with it. Right? Now, if you were to check that, it should still give out, when you were to square 5 plus the square of 8.7, that should give you the square root of 100, which would be 10. Okay? Are we okay? So that's those are questions. This is a little bit easier of this afternoon's lesson, from the standpoint that the vectors that we're talking about, well, that's just the only one vector. Okay, that's the difference between these questions that I'm showing you right now, and then the question that I'm about to show you next. Okay, the next question is probably as hard as it's going to get. It's just combining. Instead of having one vector like this one, I'm going to have two of them, and I want to find out what happens when I add them together. That's what we're going to do next. Okay, so as long as everybody's okay with that, there's some practice questions, okay? I want you guys to try them. And then I'll upload the solution. I have the solutions for those. And I'll upload them. Okay, I think I have the upload. If not, I'll try and do them, okay? Okay, so let's go down. That's a very, very important skill, okay? We have to be able to take a vector, displacement, velocity, acceleration, force, that is going to come up relentlessly for the rest of the course. We have to be able to take a vector and break it into its two pieces. That is a must, okay? It's got to have a red piece and a blue piece, okay? That's not going away. This will haunt you if you don't understand this, okay? So I will also be around after at 2 o'clock to 2:30 to help anybody who's stuck, okay? But this is very important. Okay. I'm just thinking right now off the top of my head, there's a whole, like, there'll be a question on the second summative that if you can do this, like the whole question is perfect. Just breaking things into components. Okay, so here's the problem. This is what I was talking about. Okay, instead of having just one vector now, right? There are lots of instances where we're adding two vectors together, right? And they don't. And I suppose we kind of did that this morning when we took one vector in the east direction and one in the north. That is two vectors. There's vector 1 and vector 2, and we found the resultant. The difference here is, though, the vectors that we're going to add together are no longer nice in the northeast, southwest directions, right? They're moving at angles, which seems very daunting, okay? But as long as you can deal with these things individually, it'll be fine. You'll see here, if you just create a table, you'll be able to see. This is very intuitive. If you just follow along with what I did in step 1, we're just going to do question 1 twice. Okay, and that's it. Okay, so here's what we got. We'll call this one here, we'll call this vector A. Okay, and we'll call this vector B. Maybe I'll do this in black. Okay, so I'll try to keep the same color code so that we understand what's going on. So like vectors, I'll draw in black, and then I'll break the vector into its two components, or x and y pieces, in red and blue accordingly. Okay, so everything, I'll do everything x, y's in red, and I'll do all the stuff in y and blue. Okay, so here's what we got. We got all the space, not so much space, but a little bit of space. You guys might need more space to do these questions. Okay, so what I'll do is maybe draw the vector here. This vector, I'll draw the vector. Okay, so we're going to have a normal Cartesian grid, northeast, southwest, right? We're traveling in the east direction, and then we want to go 60 degrees in the north direction. Okay, and that's our vector. Okay, and what's its magnitude? It looks like it's a displacement vector, right? Because it has meters. So let me just, that was the explanation of where that came from. Let me just slide it down so it fits in the box, okay? Okay, that's how we draw that. You're moving in the east direction, and then you go 60 degrees up in the north. If it was east 60 degrees south, east, and then south 60 degrees, you go down instead, okay? But for right now, this is what we got. Okay, we're traveling in the east direction. So now we've got an x piece, and I've got a y piece. And we're going to do the work. All we're going to do is figure out, well, what's this number? And what's this number? It's the same work that we just did. Okay, is it real okay? So let's do that. Well, nothing's really changed from the first question, right? Like x is still in the same spot as above. As in this question, it's still on the adjacent side length. So you know that x, if I was to solve for x, I'd have to use cosine. Cosine, because it's on the adjacent side length. Right? If it's on the adjacent side length and I know the hypotenuse, I better pick cosine. Okay? As you're saying, okay, that's fine. So cosine of 60 has to equal adjacent, which we're going to call x, over 50. So x is going to equal 50 cosine 60. And so x is equal to 25. Cosine of 60 is 0.5. I'm relearning this as we go. I forgot some of this stuff. It's little math tricks that save you time. Okay, and then we do the same thing as above. We go over to the y, the blue pieces, right? We say, okay, what's the blue piece for this displacement vector? Well, this time, y is on the opposite, right? So I want to know, okay, well, opposites here, and I know hypotenuse, and I know the angle. So I'm going to pick sine. sine of 60 is equal to y over 50. And so y is equal to 50 sine 60. And I don't know what the sine of 60 is. Maybe I should. I'm not sure. No, I don't. 50 times 0.866. And we're going to get 43. Okay, now it's also very important. Sometimes, as you guys would have learned in the 3U math or in calculus, or wherever you guys are in your math career, sometimes when you get dealing with trig, you can get positive and negative answers. So it's important to signify that this is in the positive y direction, right? And like sometimes we can tell that that's going to be the case. If I were to look at, for instance, let me just try to get sorted here. If I were to look at vector A, just by looking at it, this vector A is right here. You know, it went up. It went up positive in the y direction, it looks like, and positive in the x, right? If I was just looking at this vector, it looks like I've gone in the positive y and the positive x. So it makes sense that these two answers have come out to be positive in the y, and it came out positive in the x direction as well. Okay? There could be instances, if I drew a vector like, I don't know, if I drew a vector like this one. Okay, well that looks like, if I were to, it looks like it's going in the positive y direction, but it looks like it's also going in the negative x. So then you better expect to see a negative x value get in there. And that's going to come down to the angle, because that might be 120 degrees. While the cosine of 120, if I'm completely not lost, might be negative. It should be. Okay, and then that's how it controls the direction. All right. Okay, so I'm going to erase that just so it doesn't get confusing. Okay, I'm going to erase that too. So here's where we're at. Here's where this is just where these numbers are coming from. So now you're going to do the exact same work with the second vector. Right? So here you go. Well, we've got 45 meters. We're traveling in the east direction, right? So here's what we got. Going in the east direction, and then we're going to go 20 degrees north. The angle here is going to be 20, and this is going to be 45 meters. I'm going to erase that, because we know that as being the x component, or the red piece. Right? And we have a blue piece. Why? So let's just do the work. Okay, well, it's the same work. I'm going to erase that circle because it's bothering me. It's in my way. So we're going to say, okay, x is still adjacent, right? We're going to say, okay, we're going to get cosine, because it's adjacent, cosine of 20 is equal to x over 45. So x will equal to 45 cosine 20. X equals 42.3. I have these answers written down. Oh, and these are all in meters, eh? Just so there's no confusion, okay? Same thing here. Sine of 60 is equal to y over, we're now dealing with opposite, right? So that's why we chose sine, y over 45. And so y is going to equal 45 sine 60. And that answer should be 15.4. Okay, positive. It's positive because it's if I look at B, it's still acting in the positive y direction. Up. Okay. And it's acting in the positive x direction as well. Okay, so both those numbers are positive. I think it's sine 20. Did I write? Oh, you're right. Sorry. That's the only thing to be careful of, which angle you're dealing with and which question you're dealing with when. It didn't change the answer because I already have the answer, but it would have changed the answer if you guys had actually done the work. You're right, Elizabeth. Okay. Yes. It's good. You guys are following along. Okay, it's good. So if I make a mistake, let me know. So that it's not out there forever on YouTube raw. Let me know. Okay, now, what we wanted to know, if you think back, we wanted to know, and I did, it is written here. We wanted to find out what would happen if I added these two vectors together. So that's exactly what we're going to do. We're going to add them together, but we're going to add the blue stuff together, and we're going to add the red stuff together. And that's what this totals column down here on the bottom is for. We're going to get two different numbers, right? Whatever they are, whatever the numbers are, based on 25 plus 42.3. Well, 25 plus 42.3, that should be, or I'll write it down so we know where it came from. 25 plus 42.3 is equal to 67.3. That's in meters, right? And then you do the same thing here. I'll switch color. 43 plus 15.4. That should be 58.4. Now, what have you guys just found is the question. Okay, I'm going to explain it to you. And here's what's happened. You guys have, let me highlight them. We've got a vector here, A. And we found out the information for vector A. Right here, we broke it into its two pieces. And then we found, I'm going to draw it because this makes sense to me. So we found the x piece for A, right? XA. And then we also found the x piece for B. It's right here, right? And then we found the y value for A that was here. And then we found the y value for B. And what we did is we added these two together, and we added the red pieces together, XA plus XB, that's what we did, and we got numbers. What do those numbers represent? Well, if you look at it, those numbers that we found highlighted in the total column, those represent the x and y pieces of vector A plus B. Right here. You've got vector A plus B, and you have its pieces. So you just have this super right angle triangle. How do you find the magnitude of A plus B? Pythagorean theorem. So here's what you got. When you come down here, you say, okay, I've got a red piece of 67.3, and I've got a y piece of 58.4. What's the resultant? Remember, both those are in meters. Well, the resultant is this, vector A plus B. How do I find vector A plus B? Well, you've just got to do c squared equals a squared plus b squared. Right? And so you go, okay, it doesn't matter which one's A and B. You could even say, okay, let's be more specific. We'll say displacement is equal to x squared plus y squared. And we're going to say, okay, that's fine. Let's go d equals, or displacement is equal to 67.3. Oh, I forgot squared, sorry. Squared plus 58.4 squared. If you guys were to do the math on that, you should get, let me just find the number. You can type it into your calculator. I don't actually know what the number is. You guys should be okay with this, but if I go 67.3 squared plus 58.4 squared, just get the square roots, or sorry, I'll get 7,939.9. If I get a wrong number anyway, just let me know, okay? How do I get the actual magnitude? Square root both sides, right? Square root this, square root that, get d equals. I think I got it right. That's the number I have on my page. Now, these are very loaded questions, right? You can see how long this took. This took a little bit longer than what it would probably end up taking you as you get the hang of it, right? Because I'm doing a lot of explanation. But it's not to take away from how much work these questions actually are, right? When I start adding vectors together, it's a little bit of work. Now, I said something there when we add vectors together. So if I'm adding vectors, I just found the magnitude. But you guys also have to find the direction in which this is acting, right? You know the magnitude now. A plus B is 89.1 meters. We know whatever, if it's a person or something, we know that this person is now 89.1 meters from us. But is it in this direction? Is it in this direction? Is it in this direction? Is it down here? Is it like, who knows, right? That's why the vector is a vector. You need to lock down exactly where 360 degrees this person is now located, right? So you say, okay, how do I figure that out? Well, you go back to your buddy tangent. You know opposite. If you're trying to figure out what theta is, you know opposite and you know adjacent. So you say, okay, tan of theta is equal to, opposite is 58.4, and that's divided by 67.3. Tan theta should equal 0.877, 8677, sorry. Right. So you're like, oh, how do I get this by itself? Find the tan theta will equal the tan inverse 0.8677. Theta should equal 41 degrees. And now you have now found the angle at which you can put this whole vector together. Okay, we know that here's the answer. The displacement is equal to 89.1 meters east. We're heading in the east direction, right? East. And then what are we doing? We're going up 41 degrees towards the north. There is your displacement vector. And the question is over. That is what happens when you add two odd vectors together. Like they're not acting in a north direction purely and an east direction purely. You could have to add weird vectors like this, and this is going to come up in the forces unit that we're going to do in the second strand. Okay, that you guys you're going to see this come up over and over again. Okay, it's important to be able to do this. For the purposes of this unit, you have to be able to tell me what these two pieces are. Like if I just go back up to here, you have to be able to tell me nothing. It's nothing fancy. It's just, you're just going to do what I've showed you here, cosine for x and sine for y. But you have to be able to break the component that I give, the vector I give you, into its two components in order to be able to successfully answer the questions that we're going to do tomorrow. Okay, so this is an important skill. Okay, does anybody have any questions? I'm going to stop it there. That's going to be it for today. There's a few questions here, okay? There's page 71, all of which should come out of that section 2.2 that I posted. Okay, so your homework questions are here. I think I maybe even I put them on in the schedule, right? So you got that, and then you've got the ones up top, and then the stuff from this morning, okay? Lots to do. Okay, and I'll hang out here till 2:30 if anybody's stuck. Okay, this is an important skill. Okay, and we'll talk more about where you might have seen this in the past. Right? Okay, is everybody okay? Stop.